3-3, rate of change and slope. Rate of change is a ratio that describes, on average, how much one quantity changes with respect to another. So if x is the independent variable and y is the dependent variable, then rate of change equals the change in y's over the change in x. So let's use the table to the right to find the rate of change. Remember that the rate of change is the change in y over the change in x. So let's kind of determine what that means. So if y is my cost, so the change in the cost over the change in numbers. So what that means is we're going to take a look at just the first change. So 156 and 78. We have to find that change. So you want to find the difference. So 156 minus 78 over the change in numbers. So the 4 and the 2. So 156 minus 78 is 78. 4 minus 2 is 2. So this comes down to 39. So that means that the rate of change is 39, or that means that each game, so one game, is $39. So this is increasing each time by $39 per one game. For 2 games, it's increasing by 78. But for one game, it's increasing by $39. So let's pause the video to try an example on your own. The table shows how the tiled surface area changes with the number of floor tiles. Find the rate of change. So we're going to first find the change in y minus over the change in x. So the change in y is 96 minus 48 over the change in x, which is 6 minus 3. So you first want to find your change in y, which is your 96 minus 48, which gives you 48. And then 6 minus 3 is 3, so that is 16. So that means for every one tile, the area is 16, and it's increasing by that. So the previous examples that we did, we showed a rate that was constant. Most rate of changes are not constant. So for this example, they're asking you to find the rate of change for 1996 to 1998 and 2000 to 2002. So you want to find the rate of change for the 1996 to 1998 first. So you take the change in attendance, which is 81.8 minus 78.8 over the change in time, which is 1998 to 1996. And that becomes 3 over 2, or if you simplified it, it's 1.5. Then the rate of change of the next one is 92.4 minus 86.4 over 2002 minus 2000, which comes to 7.8 over 2, or 3.9. So as you see, there's 2 different numbers, which means the rate of change from 2000 to 2002 was greater than the rate of change from 1998 and 1996. So it's now wanting me to explain the meaning of the rate of change. So what that means is that the change from 2000 to 2002 was at a faster rate than the change from 1996 to 1998, because the number was higher. The rate of 2000 to 2002 was higher than the rate of 96 to 98. So to determine if a function is linear, you want to determine the rate of change among each number. So the rate of change from the first set of numbers to the second set. So you figure that out by saying -8 minus the -6, so the change in y, over the change in x, equals -2/3. Then you find the change between -8 and -10. And you want to determine that rate of change. So to do that, you get also a -2/3. Then you want to find -10 to -12. So you find the difference in the y's over the difference in the x's. And you continue doing this for the entire chart to make sure that you get the same rate of change for each one. If you get the same rate of change for each number, then you would say that the function is linear, because if we were to graph this, it would make a graph or a line that had a slope of -2/3. So pause the video for a second and see if this example is linear. The rate from the first two sets is 12 minus 10 over -1 minus -3, which comes to 1. The rate between 12 and 16 is 16 minus 12 over 1 minus a -1, which is 2. The rate between 18 to 16 and 3 to 1 is 1. So right here you would be able to determine that this is non-linear, because the rate is not constant. It is changing along the way. The slope of a line is the ratio of the change in the y coordinates, rise, to the change in the x coordinates, the run, as you move from one point to another, or you move along a line. So the formula for that is slope equals rise over run, or the change in y over the change in x. So all of those fractions or numbers that we were getting from our graphs and our functions, those were the slope of the particular line. So when you're given a line, you can determine the slope of the line by looking at a set of coordinate points. So you take the y2 minus the y1 over the x2 minus the x1. And we'll do a few of those examples in a moment. There are 4 kind of slopes that you will see in a line. A line that slopes from left to right, so it goes up, is a positive slope. A line that goes from left to right but goes down toward the ground is a negative slope. A line that is horizontal, it has no slope. It's not going up, it's not going down. It has no slope. Or a line that is going straight up and down, it's undefined. So it is going a direction, so it does have a slope, but that slope is not defined. So just like we did in the example of finding slope with a picture of the graph, I want you to pause the video here and find the slope of the lines that pass through each pair of points. So we first want to identify them as point 1 and point 2, and then our slope we know is y2, so 9 minus y1, which is 3, over x2, which is 6, and x1, which is 5. So this one would come to 6 over 1, so the slope is a 6. The next one is, we identify our 1 and our 2. Our y2 is 4, our x2 is negative 3, minus my y1 is 7, my x1 is negative 3. So this one is 4 minus negative 7, which would be a negative 3, and then it would be over 0. So now you have to determine if it's over 0, what does that value give us? We have to determine if that's a slope of 0 or an undefined slope. Anytime that a number is over 0, it is undefined, because if you were to graph this, you would graph it at the point and it would be going up and down in a vertical line, so it would be undefined. We can also find coordinates when we're given a slope of a line. So you want to plug this in just as you were if it were an equation. So we still have our m, so y2 minus y1 over x2 minus x1. So my slope is 1/3. My y2 is what we don't know. My y1 is 4. My x2 is negative 5 minus my x1, which is 1. And so now you just work through simplifying. We have 1/3 equals r minus 4 over negative 6. Now you can multiply both sides by negative 6. So this one goes away. You can multiply this side by negative 6. So negative 6 times 1/3 is going to be negative 2 equals r minus 4. So now if you add 4 to both sides, we get r equals 2. Pause the video to complete the examples below. This is going to count as your lesson review, so make sure you show me these examples to receive verification for this video.